Okay, starting with the first problem. Solving for a system of equations, you can use substitution or elimination. It's up to you which one you want to use. This problem already has y by itself, so I would recommend substitution. And in that case, this 5x plus 1 is going to completely replace the y on the second equation. So you're going to rewrite it, and it's going to be 4x plus, and instead of that y, you're going to put 5x plus 1. And then it still has equals 10. Now we only have one variable. The parentheses aren't really doing anything for us. So we can go 4x plus 5x, combine like terms, that's 9x. We need to move the 1 across the equal sign, do the opposite, be fair. On the left side, you only have the 9x, and on the right side, 10 minus 1 is 9. So when you divide both sides by 9, you find out your x is 1. Now you need to substitute it into either one of the original equations. I'm going to go with the top one because y is already by itself. So I'm going to put y equals 5 times, and since we know x is 1, plus 1, so y equals 5 plus 1, which is 6. Remember that if it's written in coordinate form, the x would go first, so 1 first, the y goes second, so the 6 second. And this is the answer as a coordinate. This is the answer without being in coordinate. Next problem, again, you're solving by either substitution or elimination. On this one, it does have columns. You don't have opposites yet, but you can do that by changing the signs. So it doesn't matter if you change the top signs or the bottom signs. I'm going to go with the ones on the bottom. I'm going to put a minus in front of that 3, change this to a plus in front of the 6t, and then I'm going to add a negative right here, so it's negative 15 instead of positive 15. Now I can combine like terms down the column, so negative 6r and negative 3r is negative 9r. Negative 60 and positive 60 cancel each other out, and 6 minus 15 is negative 9. Dividing both sides by negative 9 to get the r by itself. R is 1. Now that I know what R is, I can substitute to either one of these. I'm going to go with the top one. So it's going to be negative 6 times 1, because R is worth 1, minus 6t equals 6. You're going to multiply negative 6 and 1, it's negative 6. Everything else stays the same. And then moving this across the equal sign, I'm going to add 6. And add 6, so it's negative 6t equals 12, divide by negative 6, and t is negative 2. For the next problem, it says solve the following system of inequalities, and it has a graph. So you're going to solve by graphing. The first inequality, you start at 2. That's the y-intercept. And then from there, the slope says go down 2, and then go 1 to the right. So down 2, 1 to the right. That greater than sign does not have a line, so it's greater than, it's not equal. So it's going to be a dashed line going through those 2 points. And it's a greater, which goes above, so you shade above lightly. And there's the first inequalities graph. The second one, you're going to start at 3. So 1, 2, 3 is up here. Slope on this is a 1, so it's going to be 1 over 1. Up 1, 1 to the right. This time it has the line underneath, so it's less than or equal to, which means solid line. And then less than shades below. And you can see right here that there's overlap. So that means your answer would have this area shaded in darker than the rest. Remember, it's got to be a solid line. This one's a dashed line. Has to have the shading in this area. And that's the graph you'd be looking for because the test is multiple choice. For number 4, it says the sum of 2 numbers is 98 and their difference is 12. What are the numbers? That's going to be 2 equations. The first one says sum. That means you're adding them. So you're adding 2 numbers that you don't know. and it makes 98. Is going to be our equal sign right there. The second one is the difference, so that means you're subtracting the same two letters. That's why I'm using the same two, x and y. And then the difference is 12. This is set up for elimination because you already have opposites. They're already in columns. You could do it by substitution if you prefer, but to me it's easier this way. X and x, that's 2x when I combine it. Y and negative y cancel each other out. 98 and 12 would be 110. After that, divide both sides by 2. You find your x is 55. And now that you know one of the numbers, you can plug it into either one of these to find the other number. So if I put it in the bottom equation, I'm going to go 55 minus y is 12. I'm going to subtract 55. I get negative y equals 43, negative 43. And then divide both sides by negative 1. You get y equals 43. For number 5, it says solve by graphing. These are equations, not inequalities. We don't have to worry about shading. These both have equals, these both have equals, so you're not going to be worried about solid or dashed. First one's already in slope-intercept form. Start at 3, 1, 2, 3. Go down 4, 1, 2, 3, 4, and then 1 to the right. If you need to, go down 1, 2, 3, 4, and 1 to the right again. You want to have good points to choose from. So there's your first line. The other line, you're going to want to divide by 2 to get the slope-intercept form. So if you divide by 2, divide by 2, and divide by 2, you're going to end up with y equals negative 4x plus 3, which is going to start 1, 2, 3 right here in the same spot. You're going to go down 1, 2, 3, 4, and then you're going to go 1 to the right, and you're at the same spot again. And that means that this is the same line twice. So it could be many solutions, or it could be infinite solutions. This other one, the first one's set up in slope-intercept. So you start with minus 3, 1, 2, 3, that's down here. From there you go up 1, go 1, 2, 3 to the right. If you wanted to, you could go down 1 and 1, 2, 3 to the left. There's going to be a line that goes through those points. I'm going to do this one in standard form because it is ready to go. I'm going to cover up my y. I'm going to go negative 2x equals negative 6. If I divide by negative 2, x equals positive 3. So on my x-axis, 1, 2, 3 is right here. Then I do the same thing by covering the x up and I find out what y is. So 6y, positive 6y equals negative 6. If I divide by 6, I'm going to get y equals negative 1. That means on the y-axis, negative 1 is right here. And if I look, I went down 1 and then 1, 2, 3 to the left. So if I go down 1, 1, 2, 3 to the left, I can keep going. And if you look at that is, this went down 1 and 3 to the right. This went down 1 and 1, 2, 3 to the right. They have exactly the same slope. So that means that there's not going to be a solution. They're never going to cross. They're parallel to each other. So you would see no solution. This one's asking you to simplify. The coefficients in the front, the number negative 7 and the number 8, those can be multiplied together. So negative 7 and positive 8 is negative 56. That's completely separate from the exponents that are on the variables. Since you're multiplying a monomial with another monomial, there's no plus in between here or minus. There's no plus in between here or minus. You're just going to go one variable at a time and go, first letter is going to be the h. We have 9 over here. We have one more h over here. So 9 and 1, you're going to add them. It's 10. Then you're going to go to the next letter, I. So we have I. We have 1 here. We have 7 more there. 1 and 7, add them up. That's 8. For J, that's the third letter. You have 8 of them here. You have 5 of them there. Add 8 and 5. You get 13. And that's simplifying when you're multiplying two monomials together. Number 7, still simplifying, just more examples. So right here we have a power rule. You got to watch out. There's an exponent outside. Now when it comes to the coefficient, 6 to the second power means 6 times 6. So that's 36. When it comes to that 9 in the exponent and that 2 that's outside on another exponent of the exponent, you're going to multiply 9 times 2. That's 18. For the b, it's like a little imaginary 1 for that exponent. So 1 times 2 is 2. And then on the bottom, the 12 does not get affected by the 13. It just drops down. B13 just drops down. And then now we can deal with having the same base on the numerator and the denominator. Remember, it's like tug of war. The bigger one's going to stay, the smaller one is going to come down, and it's going to change signs. So when you bring this one down, and it's no longer up here, you're going to subtract 13 minus 2. The 36 and the 12 in the front, you need to make sure that you reduce. They can both be divided by 12. That's going to be 3 in the numerator, and it'd be 1 in the denominator. Since we have a b that's still going to have 11 as an exponent, we have something down here. We don't need to put the 1. The A18 didn't have any reason to move, so it's going to stay exactly where it was, and it's going to stay up there. So that would be your final answer. You can't do anything past that. Number 8, the 9 and the negative 6 can be reduced. Traditionally speaking, we have the negative sign either in the numerator or out here in the front. So I'm going to move it to the top instead of leaving it down here. 9 and 6 can both be divided by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. That's for the coefficients in the front. When it comes to the variables, tug of war. We have 1 on the bottom. We have 9 of them on top. There's many more on top. So you're going to subtract 1 to move it up. You're going to have c to the 8. For the d's, you have more of them on the denominator than you do in the numerator, so you're going to subtract 13 minus 7. You're going to bring that down. 13 minus 7, 6. So we have D6 at the bottom. Now we don't have anything else that we can simplify, so that's where you stop right there. Number 9, the 6 and the 9 can both be divided by 3. You get 2 in the numerator, 3 in the denominator. Okay, when it comes to the variables, you have a to the negative 7, and over here we have a to the 1. Because it doesn't have anything there, it's an imaginary 1. So that means you're going to add 7 to bring it down. It's going to meet up with the 1a that you have, and you're going to go 1 plus 7 is 8. For the b, you have 7 and you have negative 3. You're going to add 3 to move it up. It's going to come up here with that 7. It's going to be 7 plus 3 is 10. And then for the c value, you don't want to leave it on the bottom because that's a negative exponent. You want to move it to the top to make it a positive 7 for that exponent. After that, there's nothing else we can do. We stop right there. Number 10. We have some negative exponents. We have some positive exponents. The positive exponent means it stays where it's at, which is the numerator. And then these two that have negative exponents, we're going to write them in the denominator and change it from a negative 7 to a positive 7, and from a negative 8 to a positive 8. And when you get here, if you have x top and x on the bottom, that means we can put these together by playing that tug of war again, moving that 8 up, and it's going to be x to the 3rd when we subtract that, and y to the 7. For number 11, anything to the 0 power is 1, so we don't even have to worry about this side of it. That exponent is going to affect the 4, and it's going to be 2 times 2 times 2 times 2. 2 4 times. 2, 4, 8, 16. For the exponent, it's actually using the power rule, so 3 times 4, you're going to multiply those together. It's going to be x to the 12. Okay, for the simplified problems, you have to remember that in this fraction, the 3 is the radical, it's the number in the front of that root, and then the 1 would be the exponent up on top. So the cubed root of 125, you're going to want to be able to factor these out. So 5 times 25, and that's 5 times 5, and then you go, okay, I got a triple. You have 3 of them. That means that satisfies what you need to come outside of the radical sign. And if there's nothing else but those 5s, there's no need to put the cubed root anymore. So you stop right there. 5, done. For this one, you're hoping that it comes out very nicely. Otherwise, you're going to be doing a whole lot of calculator work. So let's try it. 7th root of 78,125. In the calculator, the way you make that happen is you put the root that you want. So we want 7th root, and then you do second and that up arrow. So now we have 7th root, and then 78,125. And it came out to be 5. So from there, we use the calculator. And I'm gonna go ahead and put the buttons that I pressed for that. So I pressed 7, and then I pressed second, and then I pressed the up arrow, and then I put in the number, and then I pressed equal. And that's how I found out my answer came out to be 5. For number 13, it says write each expression in radical form or write each radical in exponential form. You're just changing the formats. So on this one, you're supposed to write it in radical form. This is the radical. Remember, the 3 goes in the front because the denominator is the radical. And then there would be a 1 as an exponent, but you don't need a 1 for an exponent, so you can just leave it like that. Number 14, again, this 2 is my base. That 2 is my radical, and I don't need the 1 in the front, so I'd stop right there. That's radical form. Number 15, you want to have the same base, so you can try in the calculator and see if you can find 9 to something, make 729. So 9 to the 3rd. Hey, that worked. All right, cool. So that means that on the left side, it's 9 to the x, and on the right side, it's 9 to the 3rd power, which is the same thing as 729. Now that you have the same base, make the exponents equal to each other. If you need to do anything, solve it. But for us, that's done. Number 16 is going to be the same thing. We need to find out 11 to what power makes 1331. So 11 to the, let's try 4th. Too big. Let's try 11 to the 3rd power. That worked. Okay. 11 to the 2x minus 1 equals 11 to the 3rd power. So once again, we have the same base. That means we can make the exponents equal to each other. So 2x minus 1 equals 3. Add 1 to both sides. You get 2x equals 4. Divide by 2 on both sides. You get x is 2. Number 17, simplify the following radicals. So you need to know how to factor out by hand, because the calculator isn't going to help you on all of them. That says root, which means you only need to have 2 of these 5s for a 5 to come outside the radical. If there's any leftovers, they stay inside the radical. And if there's more than one thing on the outside, multiply them together. If there's more than one thing on the inside, multiply them together. On this one, we don't have to do that step. On the next one, you can factor out the 10, and you try to factor out the 2, but that's already prime. And then remember that the square root means you need 2 of them to come outside of your radical. The 3 was already outside. The 5 was already outside. The 2 goes outside. And the only thing left in the radical was this 5 that was all by itself. So everything outside multiplies together. 3 times 5 is 15. 15 times 2 is 30. And then on the inside, don't forget to rewrite that 5. Number 19, we're talking about zoo tickets. $10 for adults, $10 for adults, $9 for children, $9 for children. The class took a field trip, purchased 28 tickets for $266. This is talking about $10 times the number of adults, $9 times the number of children. So that means over here, you're going to put the dollars. Your second equation is just going to be those same variables. And now you're going to be talking about the number of tickets. So in this case, there was 28 tickets. That's going to be your right side of the equation. Now you can choose substitution or elimination, whichever one you like the most. But pay attention to what you're looking for. We want the students, which would be the children. So if we want to keep the children tickets, we want to get rid of the adult tickets. We're going to make sure that we multiply so that we can get the opposite of 10a, which is going to be negative 10. And then we're going to rewrite this top one the way it is. 10a plus 9c equals 266. And this bottom, the second equation, we're going to rewrite it. Negative 10a minus 10c equals negative 280. And now we can use the elimination method. And these cancel each other out. 9c minus 10c is negative c. 266 minus 280 is negative 14. Divide by negative c. Sorry, that was bad. Divide by negative 1. Divide by negative 1. And we find out the number of children tickets is 14. Okay, number 20, solving this system. They're already in columns, but we don't have opposites, which means we're going to have to multiply. And there's no way to multiply just one line. We have to multiply both lines. I'm going to go with getting rid of y. I want to make opposites where the y is at, just because the numbers were smaller. You can choose to do the x's first. It won't really change anything. But when I do this, I have to make sure that since these are the same sign, one of them gets treated with the opposite sign. The top line is now going to be 40x plus 15y equals 20. And then the second one is going to be negative 3 and negative 7 is positive 21x. Negative 3 and 5 is going to be negative 15y, which is what we wanted. And negative 3 times negative 34 is 102. Now we're going to add up 40x plus 21x, that's 61x. And then 20 plus 102 is 122. We're going to divide by 61. We find out the x is 2. And then we go back into either one of these originals. I'm going to go with the top one. And substitute x with 2. So it's going to be 8 times 2 plus 3y equals 4. 8 times 2 is 16. Subtract 16 to move it over. 3y equals negative 12. Divide by 3. Y is negative 4. And remember, if it's coordinates, you would first put the 2, because the x goes first, and then you would put the negative 4, because the y would go second.